for
Yep.
whatever.
And I do have the actual Shmoocon video that I did this weekend, and that will be going up also, and that'll go up on YouTube, and that'll make its way. The slides, the projector was really dark, so on those slides you won't be able to see them as well, but you can. I'll have the Flash actual content up, and people can download it and play it on their own and use the animations or whatever they want. So that's fine.
Yeah, that's man. I think that that's cool. I bet a lot of people are going to
Thank
watch
you.
this and be like, "Wow, that looks really tough." But I've done projects like that, man. And I think that's really fun. I can't imagine the sense of satisfaction you would get after actually achieving fixing the bearing on these drives. I mean, it's got to
Yeah.
be killer.
It's certainly been a learning adventure, and I really like, the educational component is very important to me. And so understanding more about fluid bearings, I've read a lot of white papers and gone through a lot of the IBM content and the patents and stuff. And I was quite impressed that every single little thing I find out about a hard drive everywhere has a tremendous amount of math behind it. And there's about 6 or 7 pages of math just showing how pressure actually works and how the fluid bearings actually work. And most people just thought, well, it's a post and there's some fluid in there, big deal. But those grooves and the way that they're cut and the math behind it is pretty phenomenal. And when you start reading the papers and the people that have designed it and the patents, I'm very impressed with that, and I enjoy teaching those components and adding that to my class. So I do have, to mention that I do have a class coming up in March, March 7th through 11th in Washington D.C.
Okay.
And so it's about half full right now, and I will be adding some of this content, and I try to keep discussing the new things in my new class material. So this stuff will be there. So anybody who wants to learn this process and do this process, I'm trying to scale so that this kind of content makes it in because I constantly develop stuff. I'm constantly trying to add things in,
Yeah,
and
I think it's great.
that's the goal is to educate people.
Sure. I think it's awesome. And hey, the more methods you could find for $100, it's affordable. You know what I mean? More methods
Right.
you could find to do stuff like that's really valuable.
I think so. I'm happy to help and do everything I can, and that's that hacker mentality I have. I'll buy the right equipment and I'll spend the money if necessary. It probably would have behooved the people that actually made this $6,000 tool to try to work with me to actually have me display it and show people, and maybe would have driven more people in their direction to actually buy it. But the hacker in me basically says, look, there's more than one way to skin a cat, and there's a number of different ways you can produce a tool.
Right.
And it doesn't necessarily have to be this one particular way. And so my way works, and it actually will get the job done, and it'll get smoother as you practice, and maybe I'll find other parts that actually fit in better. But for $100, you kind of can't beat it.
I agree. Now that $6,000 tool, if you use that, I can't imagine the process being much easier than what you showed with that tool, is it?
I've never actually seen the tool or seen what the parts and the pieces are. They've been very, it's a black art. We're going to hide everything and not tell anybody.
Yeah.
My understanding is, just from hearing about the tool, is that there's some parts that are milled out, and so they have specific specs for their milled out parts, so that instead of maybe doing all these measurements and things that I'm having to do, which I don't consider to be a lot, I mean, it generally takes about 5 minutes for me to figure out the measurements, put it down, and then try to go back and forth. But I think that they've got a sizer and some drilled out parts that are done in advance. But my understanding is you still have to go get an arbor press. You still have to get your the air and your clean area and your clean room and all the other stuff that would go with it. But the only thing that they've done is created a milled out basically the same thing I'm using for the bottom spacer to punch it out with the arbor press. They've made one that was mass manufactured or something instead of taken from another drive and then sanded down.
Not worth $6,000, if you ask me.
Yeah, probably not. No.
All right, let me. We got some emails here, and let's go over these. And I'll start reading the emails. And I think at last show I didn't delete the ones that we already went over. So if we start going over some repeats, let me know,
Okay.
Scott, and we'll stop.
All right.
But this one I know is new. This is from Paul. He says, Scott and Steve, I was wondering why after remapping sectors with MHDD on a Hitachi laptop drive, it did not increase its reallocated sector count in Smart, even after a power cycle. I'm starting to suspect other makes also do not update this value. So under normal use, would a remapping only occur during a format or during a write also?
I think it's a little bit kind of a, it's going to be hard for me to answer this question exactly in an easy method because when I'm comparing stuff, I actually am using a very high-end tool that would display the actual tables instead of just the smart data. The smart data is reliant upon a feature that reaches a threshold and causes it to error out, and that threshold. So, if, in other words, the head tries to read and write 10 times to a particular sector, that would cause the threshold to be exceeded. And when that threshold is exceeded, then it will actually go to the smart table. When you're actually forcing it to get rid of slow sectors and doing that, I don't know that MHDD is making that same change, that it's actually causing this error to occur in that particular region that would cause it to update, or maybe Smart isn't reflecting it correctly.
Huh.
There's a couple of situations there, but I would actually have to go through looking at like a PC3000, pull the table, compare what MHDD did, what Smart did, and try to align those three. So maybe if he has one of the tools that can actually pull the real glist table and look at it and see whether or not that was reflected in those changes, that would make sense. I believe the table is obviously updated, and so therefore, once those sectors are killed, that they're moved to the relocated table. You can usually tell by running a timing test. When you run a timing test, or if you just ran MHDD on a scan, the sectors that you would have thought you would actually get a longer delay process in for them to read because they'll take more than 6 milliseconds or 7 milliseconds. It has to go to this relocated table and then return from it. There's also another tool called Bonnie++, and there's a tool in it called zcav, and that's a Linux tool, and zcav will actually display a numeric table, which will show you how long it takes to read those sectors and where the zones are, basically, if it has to go to another zone to read it. So it's a difficult question for me to answer, not knowing his exact information and his
Right.
exact thing. But my guess is that there is something that's going on there, but that Smart hasn't hit the threshold. Smart may not be updating correctly based upon that, and that's probably true of most drives. Manufacturers don't like for Smart to update great amounts of time because it'll tell somebody that basically you have a drive that's under warranty and it'll cost us more money to replace it. So manufacturers try to not update Smart if it's not necessary under certain conditions. And that may be the case here with not hitting that threshold value. Smart doesn't get triggered.
I see. Now that data should definitely help them. But thanks for the email, Paul. This one's from Larry. He says, he's got 4 parts here. Number 1, is it better to let drives sleep, spin down during idle times, or keep them running all the time? I've heard arguments both ways on this debate, but never any conclusions supported by facts. That's a good question. I'm curious about that too. What do you say?
Yeah, I would say, generally speaking, that them spending down and not running all the time is probably better. It's better from a wear and tear perspective. However, Seagate hard drives, this is actually that firmware problem that basically gets triggered when they actually get when they spin down and they have to wake back up.
Yeah.
And if it rereads the reallocation tables and stuff like that, that's where this firmware problem will cause a problem, and the drive won't come back. And that basically the firmware bug is triggered, causing a problem that stops you from being able to read from the drive. So, generally speaking, I think that you're safe. It lowers the temperature, it lowers, a lot of wear and tear on the drive. Heads aren't flying over the platter, so it's wearing them down less. Although you've got that 5 to 10 second wait time that you're waiting for the drive to come back. That's kind of the most, annoying thing out of all of it. But, in some cases, you don't even get a choice. Recently, Western Digital upgraded some software to allow you to change the time at which these things go to sleep. But overall, you don't normally have there definitely wasn't any changes for a while that you could actually affect that it's going to sleep on its own, whether or not you wanted it to or not on the green drives and the things like that. So that's kind of the difference between some of the enterprise editions and the green drives and the low end drives, is that you didn't have the ability to change this, or that they went to sleep more often. Enterprise drives, they think they're in a RAID array or they're in a server or something, and so they don't typically spin down. They just continue to run.
Huh. Interesting. Yeah, I'm always of the frame of mind, if I'm not using something, I don't want it on. So.
Well, the old thing that actually happened was, like the idea with radios and tubes and TVs, is that the worst thing for a electronics device is when you turn it on and that power surge surges through the system.
Right.
And so that's why light bulbs blow at that time. That's why, tubes and TVs blew, things like that. Is that power surge that passes through it is the worst thing. Now, typically we've got capacitors, we've got conditioning, we've got other things that are involved. Most of your systems are fairly safe by comparison, but, again, we're still dealing with power and fluctuations and things that can cause damage. And if you got a cheap power supply, it's certainly not going to be good for the device.
So
So,
that still applies then, putting the first jolt of power through it.
yeah, generally speaking, I would say that that's probably still the most detrimental thing to the device is the second that you apply power to it, that surge that happens when it goes through
Huh,
everything.
interesting.
But generally speaking, I would say that wear and tear on the drive and how much it's running. It's kind of like if I had my car and it ran all the time, even when I was in the house. Well, certainly the pistons and the engine and everything are going to get more worn out than they would otherwise. So
Yeah.
you're probably a lot safer from a standpoint of it spinning down and not going to sleep or going to sleep instead of
Right.
not running on its own.
All right, sounds good. Number two, from a mechanical perspective, is it preferable to mount a drive horizontally or vertically? Some manufacturers' cases provide for mounting in either direction.
I think for the most part, it doesn't really matter today. The big deal is, as I just described with fluid bearings, there's going to be some pressurized stuff and there's going to be some changes. But, the drives typically are sturdy enough to run in almost any of those positions, upside down, sideways, whatever. They don't like to be moved while they're running. That typically does affect the drive. And you can see we've done a lot of things even with like vibration sensors and stuff where you can actually see like if I knock on the table, you'll actually see the drive actually vibrate. Or if I yell at the drive, there's a video out of a guy yelling at a radar array, and it actually makes waves as you're yelling at it. You can actually see that the vibrations are causing an effect to the drive.
Wow.
And that was pretty well known. It's actually always kind of been around. I actually can show that, and I do in my class sometimes where I'll actually show like the accelerometers and stuff and what's actually happening. And then if you just kind of move it around and wave it around a little bit while you're doing it, or even knock the table, you'll get a pretty bad influx of vibration. But the big thing now is that there's little metal fragments that are on the platters. Sometimes things happen, little metal pieces come off or whatever, and they get flung around the tray. There's air pressure, and basically it pushes the little metal fragments back behind this filter. And there's a filter that sits sideways in the drive, and it captures this content outside the edge of the platters. Well, the problem is that if you change the orientation with a lot of content behind it that's stuck in the filter, if anything is of any substantial size, it might fall back down inside the drive. And so when that happens, it might get stuck between a head or something else like that when the drive starts back up, causing damage. So that's why, like old servers, if you don't back them up before you move them, it might be the last time you ever saw the data. So those are the kind of things that you want to look out for. But generally speaking, horizontal, upside down, whatever, things are at least the spindle component is pressurized internally so it doesn't affect the fluid, and the heads already fly a certain height based on air pressure off the platters, so that's really not affected. So that's the worst thing that can possibly happen is maybe some fragments fall out of the drive.
Awesome. It's good to know. Number three, while I realize he doesn't support SpinRite for data recovery, what does Scott think about running SpinRite periodically for maintenance purposes just to keep the surfaces refreshed? Would it be harmful in any way?
It's only harmful in the fashion that if something bad did happen, I mean, keep in mind that this tool is picking up data, looking at the data, trying to put the data back down, refreshing the surface, which in some instances a little bit what happens when you defrag a hard drive in a much smaller sense. But I think that basically that's what SpinRite's purpose is for, is a maintenance situation where there may not be any bad sectors, or at that point in time that maybe it's something that's on the edge and it refreshes that content. I just think it's detrimental or dangerous to try to do something like that without a backup or knowing anything. But you'll probably run into a problem or the same problem that SpinRite might have run into at the same time. Keep in mind that SpinRite touches every sector on the platter as it goes across the drive. So if there is a damaged sector or there is something bad or there's physical damage where a head might be, it may cause it to dig in on the platter, causing more substantial damage.
I see.
But generally speaking, as a maintenance tool, I have no problem with SpinRite from that perspective. I'm just adamant that maybe you should make sure that your data is online, backed up, or you've got something that's going someplace. Sooner or later, it might fail, and then you have nowhere to go.
Right. Good point. Last part. Oops. Sorry, I